Welcome to my channel. Students, today we are going to discuss about kinetic energy. Okay, first of all, we have to know what is kinetic energy. The energy possessed by a body by virtue of its motion is called as its kinetic energy. That means ଯେତେବେଳେ ଗୋଟେ ବଡି ମୁଭ୍ କରୁଛି ସେ ମୁଭମେଣ୍ଟ ପାଇଁ ସେ ମୋशन ପାଇଁ ବଡି କିଛି ଏନର୍ଜି ଗେନ୍ କରୁଛି ସେ ଏନର୍ଜିକୁ ଆମେ କ'ଣ କହୁ ନା କାଇନେଟିକ୍ ଏନର୍ଜି ଓକେ ଆଚ୍ଛା ଏକ୍ସପ୍ରେସନ୍ ଫର୍ କାଇନେଟିକ୍ ଏନର୍ଜି ଓକେ here we are having a diagram. You see this is a body of mass m. Okay, when we are applying a force F on this body goes from this point to this point. Okay, acha initially the velocity of the body was 0. That means I can say the initial velocity, that is u, is equal to 0. Correct. After some time, when the body is present at this position, suppose this is the position A, this is the position B. Okay, this is the first position, this is the second position. When the body is present at point A, then it is having the initial velocity, that is u is equal to 0, and when it is at B, then the final velocity, that is the velocity is equal to v. Okay, acha here all we have discussed is written, that is m is the mass of the body, f is the constant force applied on the body. Okay, acha but u is equal to 0. What is u? That is the initial velocity. Okay, acha then v, what is v? That is the final velocity. Acha now a, okay, small a is equal to, what is this? This is the acceleration produced in the body in the direction of force. Okay, acha then s, small s. What is s? S is the displacement or distance covered by the body. Clear? Distance covered by the body. This is the distance covered by the body. Distance between A and B, point A and point B. Clear? Acha. Now let's go for the mathematics part. That is, we know the equation of motion. The equation of motion, this one you all know na, d square minus u square is equal to 2s. Okay, acha as we have discussed here, the initial velocity is equal to 0, so u is equal to 0. That means u, in the place of u I can put 0. Okay, so v square minus 0 is equal to 2as, so a is equal to v square by 2s. Clear? This is the equation 1. Acha now you see, force and displacement both are acting in the same direction. Actually, you see, refer to this diagram. When we are applying a force on the body is being displaced. It is displaced along the direction of the applied force. Okay, that means the displacement and the applied force both are in the same direction. That means what is the direction? What is the angle between these two parameters? That is theta is equal to 0 degree. Correct? So w is equal to fs cos theta, you know. So cos 0. Okay, w is equal to fs. We know that. Acha, fs means fs cos theta. F dot is, okay, fs cos theta means when theta is equal to 0 degree, so cos 0 is equal to 1. Correct? So w is equal to fs, that is equal to f jagare kete paki paribe ma. Okay, f is equal to ma, you all know, Newton's second law, into s, that is equal to, in the place of a we are having the value of a here na, in equation 1, so put the value of equation 1 here, and in the place of a you can put v square by 2s, so m into v square by 2s into s, that is equal to how much? It will be cancelled out. Okay, s cancels out, so half mv square is there. Clear? So this is the work done. This work done appears as the kinetic energy of the body. Here, due to this motion, some work is done. We found out. Okay, we are having the value of that work done, and we can say that this work done is the kinetic energy. It appears as the kinetic energy of the body. That is, k is equal to half mv square. Clear? K is equal to how much? Half mv square. Is there any doubt? If there is any doubt, you can ask me. Okay, acha next Actually, kinetic energy formula you all know from the school level, I think. Okay. Here we have calculated the formula for kinetic energy for a constant force. Okay. Here I am going for that. That was in the direct method. Okay. But here we have to calculate the kinetic energy by calculus method. Okay, by calculus method. So let's go for it. Let us consider a body of mass m. The initial velocity was 0, u is equal to 0. Okay, previously I have told you. Achha. Now what is F vector? That is the force applied on the body. Same thing. Now ds vector. Okay, this is the displacement produced in the direction of force. ds vector means small displacement we have taken. Correct? ds vector means we have taken the small displacement. Achha. So, if as the force and displacement both are acting in the same direction, okay, that means displacement is in the direction of the applied force. So I can say that theta is equal to 0 degree as in the previous one. Okay. Achha. Now the small work done, dw is equal to how much? F dot ds, that is f ds cos theta, where theta is equal to 0 degree, so cos 0 degree, that is equal to f ds cos 0 is equal to 1, you know. Okay. Achha. According to Newton's second law of motion, F is equal to ma. Clear? F is equal to how much? M into A. You all know it. Okay. In place of A, I can put dv by dt. Okay. So m dv by dt. Give it as equation 2. Okay. Now I can put the value of equation 2 in equation 1. Okay. Value of F we have got now. F is equal to m dv by dt. So we have to put this value in this equation 1. So right, putting the value of f from equation 2 in equation 1. dw is equal to m dv by dt into ds. Just f value को एटी put करवार अछि. Okay. अच्छा. So m dv by dt into ds. So ds और dv ये दिरा पोजीशन को मैं इंटरचेंज करी परिबे. Okay, as per mathematics, I can interchange this place. Okay, so I can write m ds by dt. Just ds एटी के शिफ्ट करी गला dv एपड़ होगला. Okay, ds by dt into dv. Then what is ds by dt? That is rate of change of displacement is equal to velocity. So dw is equal to how much? mv dv. Clear? Achha. The total work done to increase its velocity from 0 to v. Okay, the total work done, dw, here there is dw is equal to mv dv. V is the variable, so dv is here. Okay, up to this I think this is clear to all of you. Okay, achha. Here we have got a small work done. Okay, but we have to find out the total work done. So what we have to do? We have to integrate it. Okay. Achha. So w is equal to how much? Integration over dw, that is equal to mv dv over 0 to v. That is the limit. That is equal to m बाहर को नहीं गला पहले v dv रा इंटीग्रेशन लिमिट है लगे तो 0 to v. Okay. बेसिक इंटीग्रेशन पहले समझते जाने थे वो v dv रा इंटीग्रेशन कितने होगा? That is v square by 2. Okay. m is taken out. v square by 2 तारा लिमिट कितने ला 0 to v. So by putting the limit, okay, v and 0 like this, you will get that this is equal to half mv square. That means w is equal to half mv square. Achha. What is w? W is the work done. You all know it. Okay. So now I can say that much of work done is represented as the kinetic energy of the body. That means the amount of work done. Okay, the amount of work done will be taken as the kinetic energy of the body, which the body has acquired that energy. Okay, due to its motion. Clear? So k is equal to how much? Half mv square. Okay. So students, we can conclude that from both the type of analysis we have got the same result. Correct? the formula of kinetic energy we have got in each case, that is k is equal to half mv square. Okay, ठीक আছে पिले. In the next class we will go for some numerical part, okay, including the relation between kinetic energy and linear momentum. Okay.